The automotive industry is undergoing a seismic shift. Traditional internal combustion engines are being replaced by electric motors, and the change is happening faster than many anticipated. Electric vehicles, or EVs, are no longer a futuristic fantasy. They are now a common sight on our roads, and their popularity is only growing. They are rapidly becoming a mainstream reality, embraced by families, businesses, and governments alike. But amidst the excitement surrounding this electric revolution, a crucial question arises: are EVs truly as green as they are touted to be? Are they the ultimate solution to our environmental woes? While they offer a cleaner alternative to traditional gas guzzlers, the reality is more nuanced. The benefits of EVs are clear, but so are the challenges. A comprehensive assessment of their environmental impact requires a closer look at the entire life cycle, from manufacturing to disposal. This includes the energy and resources used in production, the efficiency of the vehicles, and their end-of-life recycling. The environmental impact of EVs extends far beyond tailpipe emissions. It's about the bigger picture, including the carbon footprint of battery production and the sustainability of the energy sources used for charging. The extraction and processing of raw materials for batteries, the source of electricity used for charging, and the end-of-life management of these vehicles all play a significant role. Each of these stages has its own environmental costs and benefits. Tesla and Rivian, two prominent players in the EV market, have taken center stage in this green revolution. Their innovative approaches and ambitious goals are setting new standards in the industry. Their journeys and strategies offer valuable insights into the challenges and opportunities that lie ahead for sustainable transportation. As we move forward, understanding the full impact of EVs will be crucial in making informed decisions for a greener future. Tesla, the brainchild of Elon Musk, emerged from Silicon Valley with a bold vision to accelerate the world's transition to sustainable energy. Founded in 2003, Tesla defied the odds, transforming from a niche startup into a global automotive and energy company. Their secret weapon was innovation. Tesla's early focus on high-performance electric cars, starting with the Tesla Roadster, captured the imagination of consumers. This strategic move helped to shed the image of EVs as sluggish and impractical. The subsequent introduction of the Model S, Model X, and the more affordable Model 3 solidified their position as a leader in the luxury and mass-market EV segments. Tesla's success can be attributed to its relentless pursuit of technological advancements in battery technology, software, and autonomous driving. While Tesla was busy electrifying the sedan and SUV markets, Rivian, founded in 2009, carved a different path. Recognizing the growing demand for adventure and utility vehicles, Rivian set its sights on the electric pickup truck and SUV market. Their debut vehicles, the R1T pickup truck and R1S SUV, promised a unique blend of off-road capability, sustainability, and cutting-edge technology. Rivian's commitment to sustainability is deeply ingrained in its DNA. From the outset, the company prioritized environmental responsibility in its design, manufacturing, and business practices. Their focus on minimizing their ecological footprint is evident in their choice of sustainable materials, energy-efficient manufacturing processes, and partnerships with environmental organizations. One of the most significant environmental advantages of EVs over their gas-powered counterparts lies in their potential to reduce greenhouse gas emissions. Gas-powered vehicles are notorious for their substantial carbon footprint, releasing significant amounts of carbon dioxide into the atmosphere. EVs, on the other hand, produce zero tailpipe emissions. This difference in emissions is substantial, especially when considering the life cycle emissions of both types of vehicles. While the production of EVs does generate emissions, primarily from battery manufacturing, studies have shown that EVs still result in significantly lower overall emissions compared to gas-powered cars over their lifespan. Section 5. The lithium dilemma, the environmental cost of EV batteries. The heart of any electric vehicle is its battery, and lithium-ion batteries have emerged as the dominant technology powering the EV revolution. However, the environmental impact of lithium mining, a crucial component of these batteries, has become a growing concern. Lithium extraction, primarily from brine pools and hard rock deposits, can have significant environmental consequences. The process often requires large amounts of water and can lead to water depletion in already water-stressed regions. The extraction and processing of lithium can also result in soil contamination, habitat destruction, and air pollution. Addressing these environmental challenges is critical to ensuring the long-term sustainability of EV batteries. Section 6. Charging the future. Can the grid handle the EV revolution? The environmental benefits of EVs are intrinsically linked to the source of electricity used to charge them. If the electricity comes from renewable sources, the positive impact on the environment is substantial. However, if the grid is still dependent on fossil fuels, the benefits are less clear. If the electricity grid relies heavily on fossil fuels like coal, the overall emissions reduction from driving EVs will be significantly diminished. This is because the pollution from power plants can offset the gains made by reducing tailpipe emissions. Therefore, the transition to a cleaner, more sustainable electricity grid is crucial for realizing the full environmental potential of EVs. Renewable energy sources such as solar, wind, and hydropower are key to this transition. Fortunately, there is a growing global trend towards renewable energy sources like solar, wind, and hydropower. Countries around the world are investing in these technologies to reduce their carbon footprints and create a more sustainable future. As the electricity grid incorporates higher percentages of renewable energy, the environmental benefits of driving EVs will become even more pronounced. This shift not only helps in reducing greenhouse gas emissions, but also in decreasing our reliance on finite fossil fuels. Investing in renewable energy infrastructure and promoting clean energy policies are essential steps toward a truly sustainable EV ecosystem. Governments, businesses, and individuals all have roles to play in this transition, ensuring that the grid can handle the EV revolution efficiently and sustainably. Section 7. Tesla versus Rivian. A tale of two sustainability strategies. Both Tesla and Rivian have made sustainability central to their brand identities, but their approaches differ in several key areas. Tesla, with its focus on vertical integration, aims to control as much of its supply chain as possible, from battery cell production to charging infrastructure. This approach allows them to optimize for efficiency and reduce their environmental impact. Rivian, on the other hand, has adopted a more collaborative approach, partnering with established companies and organizations to leverage their expertise and resources. For instance, Rivian has partnered with Amazon, which has committed to purchasing up to 100,000 electric delivery vans from the company, demonstrating a commitment to electrifying its delivery fleet. Section 8. The quest for sustainable materials and battery technologies. The quest for truly sustainable EVs extends beyond the factory gates. Researchers and companies are constantly exploring new materials and technologies to reduce the environmental impact of EV batteries. This includes developing batteries with higher energy density, longer lifespans, and lower reliance on rare earth metals. Solid-state batteries, for example, are emerging as a promising alternative to conventional lithium-ion batteries. Solid-state batteries offer higher energy density, improved safety, and faster charging times. Additionally, researchers are exploring the potential of using more sustainable materials like sodium, magnesium, and even recycled materials in EV batteries. Section 9. A Greener Tomorrow, the Future of EVs. The future of electric vehicles is bright, driven by technological advancements, innovative designs, and a global push towards sustainability. Government incentives, such as tax breaks and rebates, are making EVs more attractive to consumers, while growing consumer demand is pushing manufacturers to innovate faster. As battery technology continues to improve, EVs will become more affordable, efficient, and accessible to a wider range of consumers. This will help bridge the gap between early adopters and the mass market. The expansion of charging infrastructure is also crucial. More charging stations in urban and rural areas will make it easier for people to switch to electric vehicles without worrying about range anxiety. The transition to a circular economy for EV batteries, where batteries are reused, repurposed, and recycled, will further reduce their environmental impact. This not only conserves resources but also minimizes waste. Innovations in recycling processes are making it possible to recover valuable materials from old batteries, which can then be used to produce new ones. The vision of a truly sustainable transportation system goes beyond just replacing gas-powered cars with EVs. It involves rethinking how we move and live. It requires a holistic approach that encompasses renewable energy, smart charging infrastructure, and a fundamental shift in our consumption patterns. Integrating renewable energy sources like solar and wind with EV charging can create a more sustainable ecosystem. Additionally, promoting public transportation, cycling and walking can reduce the overall number of vehicles on the road, further decreasing our carbon footprint. As we stand on the cusp of this electric revolution, it is imperative that we approach it with a long-term vision, ensuring that the transition to electric mobility is not just a technological shift, but a sustainable one. Urban planning and infrastructure development must align with this vision, creating cities that are not only EV-friendly but also promote a higher quality of life. Ensuring that the transition to electric mobility is not just a technological shift, but a sustainable one, will pave the way for a greener, more efficient future for all.